Good day, everyone, and welcome to another problem-solving session with Special Maths Academy. In this video, we'll be discussing the problem 45 of the just concluded Nigerian Mathematics Olympiad, the first round senior category. And so this is the next number theory problem in the series. So we have m squared plus n divides m to the fourth power plus n squared minus n cubed. So I'm giving this in the question. So let m and n be arbitrary positive integers. If m squared plus n divides m to the fourth power plus mn squared minus n cubed, then m squared plus n also divides all the following except. So let's look at this. So it implies this is congruent to, so I'm going to use ideas of factor theorem, okay, for polynomials. So this is congruent to 0 mod n squared plus n, okay? So it implies that we can replace n with negative m, and so we can replace n with negative m squared, and so this is equivalent to m to the fourth power plus m negative m squared and minus m squared cubed congruent to 0 mod m squared plus n. So this is equivalent to m to the fourth power negative. So because of this is squared, so this will become positive. So this is m times m squared. So that's m to the fifth power, yeah. And because this is to the cube, this is cubed, so this negative sign is going to be retained, and it's going to, affect this one in front, so it becomes positive. So okay, so I have m raised to the m to the fourth power plus m to the fifth power plus m to the sixth power is congruent to 0 mod m squared plus n. And then we look at each of these other ones mod m squared plus n. Okay, so let's start from the last one. So m squared plus n squared. So this is equivalent to m squared. This is e is congruent to, so m squared into negative m squared plus negative m squared minus m cubed into negative m squared mod m squared plus n. And so this is congruent to, so this is m squared, this is going to be 6 power, because this is squared, the negative sign is going to be neutralized, and this will be m to the fourth power, negative sign neutralized, and then again negative sign neutralized, m to the fifth power mod m squared plus n. And we see that this is congruent to 0 from this here, so this is e is congruent to 0 mod m squared plus n, so e is divisible by that. Okay, so let's go to f. So you can pause the video and look at the algebraic operations. So I'll just erase this quickly. Okay, so d is congruent to m to the 8th power minus, so I'll just put negative m squared there to the 4th power. So we have this congruent to m to the 8th power minus m to the 6th power, yeah. Okay, and rather than going to this whole algebra for d, we see that d, we can just do difference of two squares here. So this is m to the 4th power minus n squared, and then we just add it again, m to the fourth power plus n squared. And we see that we can do difference of squares again here. So this is m squared minus n, m squared plus n, and m to the fourth power plus n squared. And we see that this always divides irrespective of the condition. So this is a very wonderful case. So irrespective of this condition, this division condition here, m squared plus n always divides d. Okay, so we can just skip this and go to the next. So let's look at C. Okay. So C, we have m to the ninth power plus n cubed. And so this is equivalent to m to the ninth power plus, so just put negative m squared cube and mod m squared plus n. So we have m to the ninth power. So this will become negative m to the sixth power. Okay. And we can do a difference of two cubes here. So this is m cubed minus m squared. So I have, let me just put it in a way that we all can follow. So this is equivalent to m cubed minus m squared cubed, which is equal to m cubed minus m squared into, so I have m cubed squared plus m cubed times m squared rather, and plus m squared squared. So this is congruent to m cubed minus m squared, and this will be m to the sixth power plus m to the fifth power plus m to the fourth power. Okay, and here again we have that this is 0 from here, so C works. So let's go to option B. Okay. Almost there. Yep. Okay. So option B is congruent to, so I just go straight. So m to the fourth power and negative m squared plus m squared negative m squared minus m negative m squared squared. So this is congruent to negative m to the sixth power, negative m to the fourth power, and negative m to the fifth power. So all mod m squared plus n. So we already have that this is negative, this is just negative of this, so this is 0. So B works, and so it would have to be A that doesn't work. So just to fulfill righteousness, we test for A. Okay, so option A. Option A is congruent to, so this is m cubed, so I'll just keep that, m squared plus negative m squared cube plus m to the fifth power, which is equivalent to n to the seventh power, so I'll just skip that, plus okay, this is negative, minus m to the 6th power plus m to the 5th power. And we see that this is not necessarily congruent to 0 mode, m squared plus n, giving this congruency. So this does not imply this necessarily. So we have that option A is our answer. And that'll be all for this video. See you guys in the next video. Don't forget to like, share, comment, and subscribe. And keep on solving maths. Goodbye, guys.